Hello students, in this video I will teach you a very important topic from the complex number system known as de Moivre's theorem. Let us see the basic idea behind this theorem. If we have any number z, either complex or real, and we take integral power of this number, then what should we get? We get a unique value. But what happens if n is non-integral rational number? That is, n belong to q minus z. Is the value still unique? No. Let us see by an example. X is equal to 1 cube. Then obviously it is equal to 1. Right? What happens? Instead of 3, we take 1 upon 3. 1 upon 3. Is there exists a unique solution? No. Because we know this is nothing but cube root of unity. Let us find those roots. Cubing both sides, x cube is equal to 1. This implies x cube minus 1 is equal to 0. This implies that x minus 1, x square plus x plus 1 is equal to 0. X equal to 1 and x equal to minus 1 plus minus root 1 minus 4 by 2 by using Sridhanacharya formula. X is equal to minus 1 plus minus root 3 iota upon 2. Iota is nothing but root under minus 1. Right? Here see, x is equal to minus 1 plus root 3 iota upon 2 and another value is x equal to minus 1 minus root 3 iota upon 2. Let us denote this by omega and this by omega square. Keeping it here, x equal to 1, x equal to omega which is equal to minus 1 plus root 3 iota upon 2 and x equal to omega square which is equal to minus 1 minus omega by 2 is omega square minus 1 plus root 3 iota by 2. Now, based on this idea, de Moivre gave two statements particularly known as de Moivre's theorem. Let us see those statements. Let z be any complex number, then z can be represented as r cos theta plus iota sin theta, bipolar representation of a complex number. Here using de Moivre's theorem, we deal with those numbers that can be represented as cos theta plus iota sin theta only. Now the statement is first, cos n theta plus iota sin n theta is the only value of cos theta plus iota sin theta whole power n when n belong to set of integer. And the second statement is cos n theta plus iota sin n theta is one of the value of cos theta plus iota sin theta whole power n when n belong to set of rationals. See, when n belong to set of integer, then cos theta plus iota sin cos n theta plus iota sin n theta is the only value of this. But when n belong to set of rationals, then cos theta plus iota sin theta to the power n has more than one values, in which cos n theta plus iota sin n theta is one of the value. Here what's happening? We are just multiplying the power with the angle theta. Let us see proof for this theorem. Proof. We know from the Cauchy-Euler representation of a complex number, cos theta plus iota sin theta is equal to e to the power iota theta. This implies that cos theta plus iota sin theta whole power n is equal to e to the power iota theta power n, right? This is equal to e to the power iota n theta, and this is equal to cos n theta plus iota sin n theta. This is the proof for this theorem. See, n is an integer, then this is the only value. But if n belongs to set of non-integral rational number, then this is one of the value. So let us find other values. Cos theta plus iota sin theta to the power n. What we are doing? Taking n is equal to p upon q, means n is non-integral rational number, means GCD. Here GCD of p and q is equal to 1, and n is non-integer, and obviously q is not equal to 0. So replace it here, cos theta plus iota sin theta to the power p upon q, and we know cos 2k pi plus theta is equal to cos theta, and sin 2k pi plus theta is equal to sin theta, because sine and cosine function are periodic with period 2 pi. So we can replace it here. This is equal to cos 2k pi plus theta plus iota sin 2k pi plus theta, and whole power p upon q, right? Now we can use de Moivre's theorem here. What should we do? Just multiply p upon q with the angle. So cos 2k pi plus theta p upon q plus iota sin 2k pi plus theta p upon q. See, here k is arbitrary, and we know here we get q distinct values. So the values of k vary from 0, 1, 2 to q minus 1, right? So these are the different values. Now let us solve two basic questions based on this theorem, right? See, this is the root of cube root of unity. So let us find out cube root of unity using de Moivre's theorem. X is equal to 1 to the power 1 upon 3. This is equal to 1 can be written as cos 0 plus iota sin 0 whole power 1 upon 3, because cos 0 is again 1 and sin 0 is 0. So this is equal to cos 2k pi plus 0 plus iota sin 2k pi plus 0 whole power 1 upon 3, right? Because cos 2k pi plus theta is again cos theta, and sin 2k pi plus theta is again sin theta. Now use de Moivre's theorem here. This is equal to cos 2k pi by 3 plus iota sine 2k pi by 3, right? And we know k varies from 0 to q minus 1. Here q is 3. So values of k will be 0, 1 and 2. Now if k equal to 0, then x equal to cos 0 plus iota sine 0, and this is equal to 1. Here we get, if k equal to 1, then x equal to cos 2 pi by 3 plus iota sine 2 pi by 3, right? This is equal to cos pi minus pi by 3, because pi minus pi by 3 is again 2 pi by 3, plus iota sine pi minus pi by 3, right? This is equal to cos pi minus theta is minus cos theta, so minus cos pi by 3 plus iota sine pi minus theta is again sin theta, sin pi by 3. This is equal to cos pi by 3 is nothing but 1 by 2, so this is equal to minus 1 by 2 plus iota sin pi by 3 is root 3 by 2, this is root 3 by 2, so this is equal to minus 1 plus root 3 iota by 2. Here it is omega. Now if k equal to 2, then you can verify by yourself that we get omega square. Now move to another question based on this theorem. Solve 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 whole divided by 1 plus sine 2 pi by 9 minus iota cos 2 pi by 9 whole cube. See, this is a complex number and we are taking integral power of this number. Then what should we get? We get a unique value. Let us find that value. Can we use De Moivre's theorem here directly? No, because this number is not of the form cos theta plus iota sin theta. So what should we do? We have to convert this number in this form. How can we proceed? We can rationalize it and solve them, but this will be a very lengthy process. So let us use this identity. We know a plus iota b into a minus iota b is equal to a square plus b square. How? See, a plus b, a minus b, a square minus b square. Identity is a square minus b square. This is equal to a square minus iota square b square. This is equal to a square plus b square, because iota square is minus 1. So a minus iota b is equal to a square plus b square by a plus iota b, right? Now using it here, 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 divided by 1 plus, keeping numerator as it is, and we are taking sine 2 pi by 9 as a and cos 2 pi by 9 as b. So what we get? A square plus b square. Means in place of a minus iota b, we get a square plus b square. So sine square 2 pi by 9 plus cos square 2 pi by 9 divided by a plus iota b means sine 2 pi by 9 plus iota cos 2 pi by 9 and whole cube. Don't forget to take whole cube. Now this is equal to 1 plus sine 2 pi by 9 plus iota cos 2 pi by 9 divided by. Just take an LCM and solve them. LCM is sine 2 pi by 9 plus iota cos 2 pi by 9. Here we get sine 2 pi by 9 plus iota cos 2 pi by 9 plus, see, sine square theta plus cos square theta is 1. So here we get 1 and whole cube. Right? Now this term and this term cancel each other and we get sine 2 pi by 9 plus iota cos 2 pi by 9 whole cube. Now can we use de Moivre's theorem here? No, because this is not of the form this. So we should convert it in this form. How? See, 2 pi by 9 is an acute angle. So by trigonometric identities we know cos pi by 2 minus theta is sin theta and sin pi by 2 minus theta is cos theta. So using it here, what we get? Cos pi by 2 minus 2 pi by 9 plus iota sin pi by 2 minus 2 pi by 9 and whole cube. Right? Because see, cos pi by 2 minus theta is sin theta and sin pi by 2 minus theta is cos theta. No worries. Now solving it, cos, here LCM is 18, here we get 9 pi minus 4 pi plus iota sin 9 pi minus 4 pi by 18 and whole cube. Now we can use de Moivre's theorem here. So this is equal to cos 3 into 5 pi by 18 plus iota sin 3 into 5 pi by 18. Right? This is equal to cos 5 pi by 6 plus iota sin 5 pi by 6. Now this is equal to cos pi minus pi by 6, because pi minus pi by 6 is again 5 pi by 6 plus iota sin pi minus pi by 6. Right? Now this is equal to cos pi minus theta minus cos theta. So minus cos pi by 6 plus sin pi minus theta is sin theta iota sin pi by 6. So now this is equal to minus cos pi by 6 is root 3 by 2. So minus root 3 by 2 plus iota sin pi by 6 is 1 by 2. So iota into 1 by 2. This is equal to minus root 3 plus iota upon 2. This is the required answer for this question. Hope you understood. Thanks for watching.